see you again. Welcome, Alex, Eric, George, Jormino. Welcome, Helmer. Nice to see you. Welcome, Ramazan, as usual. Happy to see you on every release call. Welcome, Robert, a ClickHouse contributor. Welcome, Stefan, Stuart, Teresa, Todd, Valery. So many interesting people. Interesting from which place do you join today? South Korea.
Ramazan, your birthday, is it today? Happy birthday.
Is it true? Happy birthday, Ramazan. And
here's the YouTube link. Tyler will be very impressed with us.
Yeah, I hope it works. So you have still a chance to invite your friends to watch us on YouTube. There will be a little bit of delay, like 5 seconds on YouTube. So if you're watching on Zoom, you're doing the right thing.
Cool. Let me give it another minute or so, and then we can start. Wow, Stuart is in South Korea at 1 a.m. That's some commitment.
And welcome everyone from South Korea, from Southeast Asia, Japan, Australia, if anyone, New Zealand. What is the time in New Zealand right now?
Or would it be 4 a.m. maybe?
Probably, but it's not an excuse. So thank you for joining.
All right, we normally start at 3 minutes past. Should we start?
We have so many interesting things. So let's start.
Okay, cool. I can see your screen now.
This is ClickHouse release 25.11. ClickHouse Thanksgiving release. We have a huge amount of new features as usual. 24 new features, 27 performance optimizations, and almost 100 bug fixes. And let's start with something small and nice, like new system tables, new functions that we add at every release. And the first one is a new system table, system Unicode. A table for introspection and searching inside a Unicode table, a table of code points. For example, you can search for all emojis related to leaves. Let's check it. Let me run ClickHouse local on my machine. Here it is. I'm running it as easy as CH. And let's look what is inside this table. Describe system Unicode. And there are 120 columns with interesting properties. And some of these properties are like fairly technical. For example, if it's a diacritic mark, if it's like grapheme base, whatever it means, is it a hex digit? Some of them are enumerations, like which script it is, probably Egyptian or whatever. And let me show just a single query. This query selected all the code points related to leaves and grouped by the Unicode block. So we have these nice leaves. Okay, it's pretty simple. What is next? Another function, named flip coordinates. It is fairly simple. If you have a point with 2 coordinates, like latitude and longitude, it will just flip it. But if you have a more complex data type, like line, string, ring, polygon, or multi-polygon, it will go inside and flip coordinates inside every point. There is nothing special because it was already possible. For example, polygon, it is represented as an array of arrays of points, where the first array inside this arrays is like outside boundary of the polygon, and subsequent arrays are holes inside this polygon to cut. So it's like two-dimensional arrays. And if you want to flip all coordinates, you can use the function reverse and wrap it inside two applications of higher order function array map. But it is not so convenient. It is way more convenient to just write flip coordinates, easy, and it works for all of these geographical data types. Moreover, it is compatible with PostGIS function st_flip coordinates. And what is the purpose? The purpose is to unify and integrate different software that for some reason take coordinates in different orders. Like most databases, including ClickHouse and Postgres, have the order of longitude and then latitude. But most of visualization software like Google Maps and other maps, for some reason, they have it in the opposite order. And you have to do something for that. So it's pretty nice. And the next one is yet another function for compatibility with Postgres. It is named array remove. In ClickHouse, if you want to just skip certain values from an array, you can use a really powerful function, array filter. It accepts a lambda function, which allows you to filter by any criteria you could even imagine. So it already existed for 7 years or 8 years, all the ClickHouse history. It is way more powerful, but now we have a less powerful function just for compatibility. And its application is actually simpler for this particular case. And we have it in the ClickHouse style name, camel case, array remove. And with Postgres style name, array underscore remove. So nothing special about this function. It works, it exists. Use it if you need it. And now another function. We have so many new functions. It is named CumDist, cumulative distribution. And this function also exists in Spark, Databricks, Snowflake, and Postgres. So why not to have it in ClickHouse? And since version 25.11, you have it in ClickHouse. It is very similar to another window function, %rank, but it is slightly different. To demonstrate how different it is, let's look at the demo. For the demo, I will run a query inside the ClickHouse web UI. I have a table named UK price paid. It's all the recordings about properties sold in the United Kingdom, like houses, like apartments, flats, and so on. And let's calculate 4 different metrics. Actually, no, 5 different metrics for each county. First, we will calculate the median price across all the data, all the years, median price of home sold. And we will also sort by this median price, so we can look at the cheapest counties like West Glamorgan. I don't know what it is. Mark, are you in the UK? Occasionally.
Yeah, my geography is terrible though, so I don't even know exactly where that is.
Okay, probably
We have to get a
it's
map.
in the middle of nowhere, but it has very cheap homes for sale. Actually, no, it's in the west of nowhere. In the middle of nowhere is mid Glamorgan.
And then South Glamorgan in position 8.
Yeah. And there are a lot of strange stuff.
Stick.
Middlesbrough. No, Middlesbrough.
Yeah.
It should be in the middle of nowhere. Yeah, and it also has cheap
That one is
prices.
a bit more to the north, though.
Ah, okay. And this county named Bournemouth Christchurch and Poole, it is the most expensive. Although Christchurch should
It's
be
only
in
got
the...
one.
just one one home, so it's probably it's like very exclusive. But Christchurch, that is not in New Zealand, it should be expensive. Okay, and we calculated 4 different metrics. The first is the ratio of the median price to the maximum. We did it with a window function, max over, and we just divided this price to the maximum. And we can see it ranges from 0.13 to 1. Okay, the next metric it's quite similar, but it is different. Here we calculate the ratio between a cumulative sum to the total sum. So we will sum up these numbers cumulatively and see the percentage. And here how it goes from 0 to 1. Nothing special, almost uniform distribution, but not quite uniform. And here are another metric, percent rank. So it is like taking this metric, but just normalizing it to uniform like progression from 0 to 1. So instead of a particular value, it will show where this value stands in the whole range. So if it is in the middle of the range, it will be 0.5. Let's take a look. So 0.5, it should be a median, and the median county, which is the city of Peterborough, sorry, it corresponds only to 30% of the cumulative price and 44% of the maximum price. Okay, it looks like I'm trying to mess up everything. And this function percent rank already existed. The new function cum_dist, it is very similar, but with just slightly different coefficients. So again, it calculates something similar to percentile, but actually the number of records that is before the current record, including the current record. So instead of starting with 0, it starts with 1 and again it goes up to 1. So almost the same. Okay, but if you are confused, you can look at the documentation and not necessarily ClickHouse documentation. You can take a look at Postgres documentation. You can take a look at Snowflake documentation, because this function is exactly like in any other database. What else? Oh, another function. This function is named midpoint. It is a regular function, so not window function, not an aggregate function, just a regular function. And it is similar to other functions like list and greatest. And you know that list takes a few arguments and returns the least one, like 1. In this example, the greatest returns the greatest one. And midpoint, easy to guess, it returns a midpoint. And in this example, it is not really convincing why do we need to have this function. But actually, it becomes more interesting because it can take date and date time data types, and it will return the closest value to the average of the arguments, but the value of the same type. So if the arguments are date, it will just round to the closest date to the midpoint. And if you are wondering what is the midpoint date between now, November 25th, and the new year, it will be December 13th. Easy. Thanks, Simon Michal, for implementing this function. Oh, more functions. Now aggregate functions. Arg and min, and arg and max. Keep in mind that we already have functions argmin and argmax. So what is the difference? Let's take a look. If you want to just get the maximum price across all the data for 2025 in the UK, you just write select max price. That's easy. If you want to get the record corresponding to the maximum price and take another field from this record, like what is the town where the price was the maximal, then you use our existing function argmax. Argmax, where the first argument is arg and the second is max, and it will return the town. What if you want to get a pair, town and the corresponding maximum price? You can already use it. Just use the tuple as the first argument. Argmax of tuple, town and price, and it will return this tuple. And there is nothing new, it is already available in 25.10. But the point is, it is not so efficient. It will allocate memory for price and then for price again. And not so natural. You have to write it twice. And for this reason, we have a new function, arg and max. It is similar to argmax, but it will return both the arg and the max in a tuple. That's pretty easy. I'm not even going to show it to you. Okay, now something, not just a function, something else. A new virtual column for queries from external object storages. S3 compatible object storages, including AWS, S3, and GCS, and obviously Minio, and a lot of other compatible things. We have already a lot of virtual columns that you can select among your data. So let's imagine you process a bunch, like thousands, maybe millions of Parquet files on S3. And in addition to the data inside files, you want to also extract some metadata about the files. And for this, we already have columns like path that will return the full path, file, just the file name, size, which will return the file size, modification time, this is underscore time, etag, which is like modification hash, just a certain string that will change with every modification. And the new one is named tags. And it is kind of special because in AWS S3, if you want to modify the file anyhow, if you want to change it just a little, if you want to append 1 byte to a file, you cannot do it efficiently. You have to basically recreate or copy it. And this is true for all of the things except tags. Tags are like a small set of key value pairs that you can attach to your files and modify without touching the file itself. But until recently, there was no possibility to extract these tags back and use them in ClickHouse. Now there is. Just select tag and it will tags, and it will return a map of string and string. Okay, that was about small features. Now what about performance improvements? We have a lot of performance improvements because we optimize ClickHouse, and then we optimize ClickHouse again. And then we are not satisfied and optimize it again. So what do we have? The first one is quite interesting. The possibility for using projections as indexes. Actually, you can imagine, and maybe you already imagine projections as indexes, because it is like a data structure inside your table that automatically optimizes your query. And typically you use it like this. You have a table with a certain order. In this example, it is a table with page views, and it is ordered by something like a counter, JavaScript counter identifier, something like a website, something like this. But sometimes you want to do range queries by event time, regardless of the counter ID. And for this reason, you can create an ordering projection with all of the columns from the table, but ordered differently. And if you do range queries by event time, these queries will use the projection. The downside, it will physically duplicate the data. The table will take twice more space on disk, which is not really nice. Actually, it's okay. The question is, can we make it even better? We can. In ClickHouse 25.11, there is a feature when you can create a projection with just a single column. Instead of select star or select your subset of columns, you just select a single virtual column part of set. Select _ part _ of set. Order by your desired order. And this projection will materialize offsets in the storage, and then it will use these offsets to look up the records in the main table. So point queries will be accelerated. Like if you select like tens, like hundreds of records, maybe, I don't know, thousands, it will locate offsets, then read in the main table, like scatter gather type of read. You don't get the most optimal data locality, but for point queries, it will be enough. Actually, let's take a look. I have a server on my disposal. Let me connect to ClickHouse. And I have 3 different tables where I created. I have the original table, a table with projection, and a table with new index type of projection. So here is the first one. It is named hits, and it is just a table from our benchmark, ClickBench. This is how it is ordered. Now, what about hits with a full projection? Let's focus on this part. We have a projection by time, which duplicates all the columns, ordering them differently. Okay, so it should work. Another one is a new type of projection, which works as an index, exactly as I explained it. Okay, Now take a look at the, let's take a look at the storage size. We will use system tables. By the way, it's important to never forget to specify the database where you select from, because otherwise tables with similar names will be possible to find in different databases. Okay. And the original table is 13 gigabytes. The table with index type of projection is just 14 gigabytes, like plus 1 gigabyte. Not a lot, maybe less than 10%. But the table with full projection is 38.5 gigabytes. And I expected it to be like twice large than the original, 26 gigabytes maybe, but it is 38. Almost three times more. And now I have a question for Mark. Mark, what do you think? Why? Why adding a projection with the same data not duplicated the storage, but made it triple?
It's probably because the way that we have it sorted initially is removing a lot of duplicates. Maybe they are next to each other in the original order, and they're no longer next to each other when we do it just by event time. Or what was that
Yeah,
what we did?
exactly, absolutely. The answer is right. Because the previous order, the original order was much better for compression. The order by event time is almost random, and the data does not compress well. But interesting to test the performance. How will it compare? I will use ClickHouse benchmark. It's a tool packaged with ClickHouse. You have this tool as well. And we run this query. It's a point query, selecting all the records for a particular second. Now from the original table. 45 milliseconds. Here is a query from a table with full projection. And I expect it to be the most optimal. It will be not 45 seconds, but Mark, would you like to guess?
Oh, let's see. Okay, everybody has to have a guess. Let's see who's going to get the closest.
Okay.
So what's it's 0 point? Which one are we doing? Which percentile?
Full projection.
Yeah,
So
which number? The
it was 45 milliseconds, 45.
45. So what's the 50th percentile we're doing?
Okay, so you guessed like 23.
Yeah, okay, I'll do 23. Stuart Hans says 10. Let's see if we've got anybody else gonna play as well. So Reach says 1.
1 millisecond.
Okay,
It's a
who
good
else we
guess.
got?
I like it.
Stefan, 11. Stefan says 11. Okay, that's enough guesses, I think. So I said 23, and it's what is
16.
it? 16. So who's
Yeah,
the winner?
median. 16 milliseconds. Yeah, it's
Stefan
close to
might be the
10,
winner.
but also close to 20. So you both
Yeah.
are the winners. Okay, now what about the index projection? And I should say that the index projection is like not complete. It will have to do more work than the full projection. So it is expected to be somewhat slower, but it is also expected to be faster than the original query. So something in between of 16 milliseconds and 45 milliseconds.
Okay,
Yeah,
Stefan says 21.
21.
Alexi says, another Alexi, different Alexi says 3.
Oh,
So what will this one do? So this one will be able to find the actual record quicker than if it was using the initial approach, but then it will still have to go and read all those columns, the 3 columns that you returned
yeah.
from wherever they are.
And actually, there are many records for this particular second. Probably 100, maybe 1,000.
Okay. But it maybe they will be in the same, well, I guess they should be in the same granule, right? Given we sorted by the event time.
No,
Ah,
because it will be in the same granular for inside the projection.
oh,
But then,
that's right.
uh-huh.
Huh. And then it has to go and look it up in all the initial ones.
Mhm.
Okay.
Okay,
So I'll
let's.
say 30. Stuart
Oh,
says 31.
very, very close. Very, very close. So
Ooh,
it is 27 milliseconds.
27.
And actually, it is really good. It is almost twice as fast. And the benefit will increase with the size of the table. This table has just 100 million records. If you have 100 billion records, the benefits will be way more.
And then you said it was, well, you said it was not complete yet, the feature. What's the next thing to do to it?
Actually, it is fairly complete. I
Oh,
think
okay.
maybe we should make it simpler, because why define projections with this syntax if we can just define it as an index? And also, there are many things we can do with projections. For example, again, in 25.11, any projection which does group by, like in this example, we have the same table and mobile phone model, and we have a projection calculating statistics for each counter across the different mobile phones. And this projection typically speed up group by queries, but now it will also speed up distinct queries. And it is kind of obvious. You might be wondering why we did not have this feature yet, but today we have it, so no concerns. What else? A speed up for a particular case of group by. You know, group by is probably the king of all operators, relational operators inside ClickHouse. There are the largest number of specializations, the largest number of interesting cases, and the largest number of algorithms we combine together just to implement group by. And this optimization is probably for maybe 1% of queries you find on production, but we found this opportunity to optimize, and we did it. So let me explain. Let's suppose you are doing group by a small integer, and this integer has just 8 or 16 bit. So it ranges from like 0 to 255, or maybe like 0 to 1000, or like in this example, just from 0 to 99. But the aggregation state is quite heavy. A typical example of heavy aggregation state is count distinct or approximate unique, especially if you aggregate a lot of values inside this aggregation state. And in the previous version, everything was fast except the latest stage, merging of different states from different threads or different servers. Now we parallelized the merge. And to prove the point, let me just copy paste it. Oops. Copy paste and run. No, I have to use my machine where I have the new version and the old version. And first I will run version 25.10. Here is ClickHouse client. It is connected to 25.10. Now let me run this query. In the previous version, it takes 4 seconds. Yeah, 4.5 seconds. It's not bad. But now let's test the new version. Here it is, my precious server, the latest build from master, built on my machine. And the same query. And now let's guess again. Let's do this guessing game. First
Okay,
mark.
so the initial is 4.5 seconds. So we're hoping faster than that. Let's see. I will say, what will I say? Maybe I'll say 3 seconds then.
Oh, okay.
We need some other guesses. 2.7 Ramazan. Stuart says 4. Stefan says 250 milliseconds. Herb says 2 seconds. Cool, we got it. That's probably... Helmar says 0.5.
Oh,
Alexei knows the answer, so he can't tell us.
okay.
All right,
So let's run it.
let's see.
2 seconds.
2 seconds.
Okay.
Herb is the winner.
So we slashed the time twice. Actually, more than twice. So who is the winner?
Herb? Herve. I'm going to say Herb. Hopefully I pronounced it right.
Let me see. Okay. I will not risk that. So congratulations for the winner. What else? Optimization for memory usage for very large tables. Tables with a huge number of data parts. This optimization is implemented simply by not storing identical column descriptions, like columns with names and data types for different data parts. If they are the same, they will be stored only once. And we tested it on our cluster that we use for development, the cluster for CI logs of our testing infrastructure. It has more than 2,000 tables, each of them like 300 columns on average. Some tables have 2,000 columns, some tables have 100 columns, with 27,000 data parts and 21 trillion records, with half a petabyte of compressed data. And all of this inside just a single shard. It is ClickHouse Cloud. ClickHouse Cloud scales by replicas. Every machine is identical. It looks at all the set of data. And in this case, before optimization, just the metadata took 12 gigabytes. The servers were pretty big, maybe like, not really big, but probably like 100, maybe 200 gigabytes of memory. And we just saved 12 gigabytes, almost for free. And it will be especially useful for you if you also have huge tables, a huge number of data parts on just a single machine or on a replica of a large cluster. I know 21 trillion records is not, it's not a record. People store hundreds of trillions records and even quadrillion of records. I know this. I know these guys who do that. Okay, what else? distributed processing of large external files. It is again for the case when you have just a bunch of files on S3, or when you have a data lake and you query this data lake. And if you have a large bunch of files, like you have hundreds of files and you have 10 machines, then you just query these files and everything will be parallelized across these machines. But there is another case, it's quite popular, surprisingly, when there is just a single large file or just a few large files. And now we parallelize everything across different units of work, different ranges, row groups inside these files. And different servers will just take and eat different portions of every file. Okay, now about more interesting features, even more interesting. And the first one is fractional limit and offset. Sounds quite obscure, but actually it's a good feature and you will find it really useful. Now, when you write limit, you can write not just the number of records, like limit 100. You can write a ratio of records, like limit 0.25, and it will take the first 1/4 of the result. Why do you need it? Let's suppose you run a query and you don't know how many records are in the result, but for some reason you want to sample it. And it is especially useful to sample from the middle of the table. And actually, you can use window functions for that, subqueries, but it is not so convenient. It's way more convenient to say something like take 100 records from the middle. Okay. Another interesting feature is user impersonation. Now you can authenticate as one user and do the work like selects, inserts, alters, whatever, as another user. All you need is to have this new grant impersonate for you granted for a certain user, and you allow to impersonate another user or just anyone. And then you can execute any query on the user's behalf. Or you can even set it for a session, for interactive session in ClickHouse client. And the use case is fairly practical. Use a certain user for like API authentication, but use all the mechanics of access control, limits, quotas, using ClickHouse configured users. What else? A new data type, named geometry. So we already had all the data types we needed: point, line string, multi-line string, ring, polygon, multi-polygon. But now you can use just a single data type, geometry. You can create a table with geometry data type and insert a polygon and then multi-polygon and then line string and then point. And this geometry data type will accommodate everything among these data types. And the new functions like read WKT, which is well-known text for geometry. It's a standard format. And there is also well-known binary, also a standard format. If you know GIS systems, you know these formats. They will just parse and return a geometry value. And this is just a small thing for a small part of quite rich set of functions in ClickHouse for geography and geospatial processing. We have H3 indexes, S3 indexes. No, S2 actually. S2, it's from Google. Geohashing, optimized distance functions, optimized polygonal dictionaries, and so on. Now something even more interesting for those who operate ClickHouse on production, especially distributed clusters, especially regionally distributed. Now you can configure ClickHouse so it will automatically request and provision and use TLS certificates. And when you have a cluster, one server can request a certificate and other servers will share it. So even if you have different endpoint servers, one of them like in the United States, another in Europe, another in Southeast Asia, they will exchange the certificates and all of them will be properly configured. It uses HTTP challenge. It integrates with Let's Encrypt, but not only Let's Encrypt, also like Zero SSL, other compatible providers. All you need to do is to provide this configuration and it will do the stuff. It will exchange configurations using exchange certificates using ClickHouse Keeper. Pretty nice feature, right? And yet another feature, really interesting. I promise. So text classification with lightweight models, Bayesian models. These models just compare the frequencies of sequences of bytes, sequences of code points or tokens, compare with reference frequencies, and use the Bayes formula to calculate the most probable class. And this way you can classify character set or language with certain precision, or even topic, or even like spam. Although it's pretty rough, but it still remains practical due to its speed and simplicity. So you can use it for massive data volumes where using something like large language models is not practical. And let me show you really quickly one example. So I have this model configured on my server. And I have a data set from the internet. It is named mini crawl. It contains internet pages and the text extracted from these pages. And with the function naive Bayes classifier, I will just calculate the class, and the class is just an integer defined by a model. So it's like an abstract identifier, but I know that it corresponds to a certain language. And the class what in this model will correspond to Chinese. So what are Chinese, not traditional, like simplified Chinese? What are websites with simplified Chinese? It's not the right server. I have to go to the server. And yeah, it works like 0-php.com or 017qq.com. QQ is probably Chinese, I don't know, but this is 0000.cn. It's definitely Chinese. Okay, it works. What about another language? Russian? At least I can validate the results. Okay, looks plausible. Yeah, all Russian websites. So it works. What else? What about data lakes? Every release we have something for data lakes because there are so many different data formats, so many different data catalogs, And even if we will implement like 1 or 2 new data catalogs every release, it will be not enough. And now we have support for Microsoft Fabric One Lake catalog. Sounds nice. For some reason, I want to say something like ClickHouse subsystem for Microsoft One Lake. What does it give? It is compatible with the Iceberg REST catalog, and the tables are Iceberg tables. So all you have to do is just create this catalog with this endpoint and copy-paste identifiers like warehouse identifier, data item identifier, tenant ID, client ID, and the secret token. I could probably show it to you, maybe just to check if it works. I have the latest version installed, and let me just create it. You can even see the real credentials, but don't worry, we will wipe these credentials just after the presentation. Okay, it was fast. Did it do anything? I hope so, because now I'm going to run this query. Okay, Mark, one question to you. Will this query run successfully?
I mean, hopefully it will, yeah.
Let's see. Yeah, hopefully it does
Starting.
some. Wow, it runs successfully, 22 seconds. Not bad. Here is the result, it works. So now we officially have one lake integration, it is working. Yeah. What about other integrations? A lot of stuff like ClickStack now has support for alerts, so you can not only look at your metrics, look at dashboards, configure dashboards, you can also configure alerts to your email, Slack, a lot of different destinations, and a lot of updates for language drivers and for connectors like Kafka, Spark, Flink connector, dbt integration. ClickPipes now support Azure Blob Storage as generally available. Until recently, it was just private preview or beta. Now it has not only S3, also Azure Blob Storage. Now bonus. Actually, I have a few. I have a few bonuses. The first one is chDB update. It is a new version 3.7.1, and the main result, it is almost twice faster than the previous version. For several reasons. A better integration with memory allocator, a newer ClickHouse version inside, and faster operations with Apache Arrow. And if you didn't know, chDB is like a full ClickHouse engine, full ClickHouse query processing inside your Python script. And by the way, it's not only for Python, it can be embedded in many different environments. And this one, Stockhouse. It's a new demo website for real-time analytics on crypto exchanges and also real stock market. And what I really like, it is real-time. So we can look at the chart like Doge to USD or USDT to USD and change the refresh speed to milliseconds. And it updates every 50 milliseconds. A nice way to demonstrate the power of ClickHouse. The next one is another demo project named velocity.clickhouse.com. It is my project. I created it on top of ClickHouse data. And initially, I just wanted to have a report about how managers inside the company actually look at GitHub issues. Sometimes I say managers, sometimes I say managers. And I just want to validate certain thoughts about how the work is distributed. But it was boring and I did not get any results. So instead, I created a website to compare different repositories. For example, you can compare ClickHouse and Apache Spark, or whatever you want. Any public repository, any organization on GitHub, velocity.clickhouse.com. What else? This is especially interesting, and I like it a lot. It is about LibreChat. And LibreChat is the most popular and probably the only popular tool for building chat-based AI applications. Applications that look like a chat, but actually include a lot of stuff like tools, tool calls, like artifacts creation and sharing, like agents, sandbox execution for programs. And all of this is inside this open source tool. It is unbelievably popular. And what I'm especially happy about is that the team behind this tool now works at ClickHouse. If you did not check it, it is open source. It remains open source. What else? We are going to have a party in Las Vegas with the chain smokers. We like chain smokers because it starts with CH, like ClickHouse. You might like this music, you might not like this music, but you will be definitely happy to spend time with ClickHouse engineers and ClickHouse friends. So if you are going to be at Las Vegas on December 2nd, visit the nightclub where it will happen. By the way, it is quite limited, so maybe you have to rush just to get the tickets. And we are going to host a lot of meetups. In Warsaw, it will be tomorrow. In New York and San Francisco next week. In Tokyo and Tel Aviv in late December. Okay, and we have a lot of interesting content about LibreChat, about ClickStack, OneLake, chDB, about fighting crypto scams with ClickHouse, about AI-first data warehouse for business analytics, about Japan Cloud and what does it mean for ClickHouse. A lot of stuff. And now we have about 1 minute for your questions.
Let's let's see if anybody has any questions. Stuart has a very long question. I'm just trying to see if we can shorten this. So
maybe I can read it. I don't know.
When we create users profiles and roles using ClickHouse DDL, they get stored locally and basically then want to propagate them somewhere else to another shard or replica. Is there an easy way to do that? Users profiles and roles to another replica.
Yeah, there is an easy and natural way to do it. You just use keeper access storage. And when your cluster is connected to shared keeper, it will just share and update all the users, settings, profiles, access control, quotas, everything from keeper. We use it in production in ClickHouse Cloud for more than 3 years. It is available in open source. It is available for everyone. So this is the natural way. I use it on self-managed cluster as well.
Cool. And then from YouTube, Avery asks, does the Let's Encrypt integration update the in-memory TLS certificate and on the file system?
Yeah, that's an interesting question. And actually, I don't recall. We just configured this integration on one of our demo services. And I would like to ask the author of this feature. I would expect, actually, I would expect this certificate to only remain inside Keeper, so not be stored in any file system. It will be like the most natural implementation, and I expect it to be this way, but I will have to clarify.
Cool. Mohammed asks, is there any updates on text search? I think that was made beta in this release. Docs.
Technically, it is private preview. I always ask my colleagues, would you like to promote text index to beta or maybe to production or whatever? And they say, it's private preview. We are not entirely certain. We are certain for 90% that the data format will not change, but not for 100%. And that is why it is technically in the private preview. But I expect in 25.12 it is going to be better, or maybe if we will be especially lucky, it will be GA.
Robert says beta in 3 to 4 weeks. So just Christmas Day or something.
But I already use text index, and I'm really surprised by how it works. I even created an index on the table of 300 terabytes with the code from GitHub, and I can find things like open AI tokens that are still working. I did not use them, but it's funny.
And Stuart says the website flickers when you use Google Translate. I'll pass that one on to the web team. Stuart, I don't think Alexi can fix that one.
Yeah, I'm not a JavaScript engineer.
Yeah, me neither.
Although sometimes I'm pretending to be.
Mohammed says full text search says it's in beta in the docs. So Robert says we're going to fix that. So there we go.
Yeah, interesting.
Not yet beta. Cool. I think we're done though. We're pretty much there, and then I guess we're gonna do one more just before Christmas for 25.12.
Yeah.
But I don't know when it is. We'll have to ask Tyler. So yeah, keep an eye on the ClickHouse LinkedIn or Twitter or emailing list or whichever thing you use. And Stefan says, bring the sharded maps for Christmas. It's your favorite question, Alexi.
Yeah, I also would like to see sharded maps. but to be honest, it is not the highest priority feature. After we have the JSON data type, it takes maybe 90% of use cases for sharded map. These use cases still exist, and yes, I want to have sharded map, but probably next year.
Okay. Cool. All right. Thank you, everybody, for joining us. I guess if you're in Australia, probably time to go to sleep. Otherwise, everybody else, have a good rest of your day. We'll see you next time. Bye.